So today we're gonna be continuing our JAMB lessons, and I hope you guys are aware that JAMB registration started on 19th, 19th of this month, and very importantly, you're supposed to get prepared. So we're gonna be continuing our lessons so that we can get prepared. Okay, so let me quickly share my screen. Um, Miss Victoria, let me know if you can see my screen. Can share screen quickly.
Okay, I can see it yet.
Okay. Okay. Yes, can you see my screen now?
Yes, sir.
Okay. Okay, so let's um so Victoria, tell me, are you aware of our YouTube channel?
No.
Okay, I'm gonna show you now. Don't mind, my network is pretty slow. Okay, so this is our channel, Tclassified.com. Very, very importantly, once you get to the channel, you click on playlist. Okay, then at playlist, you can now see the various. You just scroll down, you will see the various subjects the way you want them. So this is JAMB, this is chemistry, English, literature, physics, biology. You can see the way they are arranged. So the easiest way to get to them will be to click on playlist first. Like if you just get to the channel without clicking on playlist, you're gonna see our recent videos, and some of those our recent videos, they are not like arranged in such a way that would take you from the basics to where you want to be. So you have to click on playlist first. Then once you get to playlist, you can now scroll down, get to JAMB, and pick out the course that you want to study. Okay. So Mondays is always for physics. So I'm gonna click on this physics class. I hope you are doing physics.
Fine.
Okay.
Any short, sharp pain is usually the first sign of sensitivity. The light.
Okay. So once you open up physics in the playlist, you're gonna see the different topics. In physics, you're supposed to have introduction to physics, where you have the definition of what physics is, then measurements, then dimensions, then examples of dimensions. Please, can you mute yourself? Then units and its multiples, then the various measuring instruments and how to use them, like how to use linear calipers, micrometer, screw gauge, motion, and the rest. Okay, so I remember that we've already looked at introduction to physics, dimensions, and measuring instruments. So I want us to quickly discuss them now, so that we know where we are and we know where we are heading to. So we looked at measurement, and we said that when you want to measure, you are actually measuring. You want to like get to know the size of a quantity, because without knowing the size of the quantity, you cannot really uh, understand the magnitude of that quantity. Let's say you want to say that you are bigger than your sister. How do you know that you're bigger than your sister? Or how do you know that you weigh more than your sister? You need to measure your weight. You need to get on a weighing balance. Then, when you go on a weighing balance, if the weight that the weighing balance rates for you is more than what it rates for your sister, that's when you can say that you are actually heavier than your sister. Because men looking at you and your sister, you might be thinking that you're heavier than your sister when you are not actually heavier. So you have to measure in order to ascertain the actual magnitude of your weight vis-a-vis that of your sister. So measurement is very, very important. And there are many things we can measure. You can measure length. When you measure length, we say that length is measured in meters. You can also measure mass, and mass is measured in kilometers. You can also measure time, and time is measured in seconds. So when you say that weight is measured or mass is weighted in kilogram, simply means that kilogram is the unit. When you say that time is measured in seconds, it simply means that seconds is the unit for measuring time. And when you say that length is measured in meters, it simply means that meter is the unit for measuring length. So units are very, very important. Once you attach units to a quantity, you're able to tell the person reading your quantity what kind of quantity you're trying to measure. Okay, so that was what we looked at the last time, and I'll go over it again, and I'll start actually from scratch. So let's look at physics, which is what we are supposed to learn today. What is physics? What is physics? So physics is actually the pure science that deals with the behavior of matter and energy. That very pure science that deals with the behavior of matter and energy and re- how it relates to other physical quantities or physical properties is what we call physics. That is what we call physics. Okay. So, what are the outcomes, learning outcomes for today's lectures? I want you to be able to define physics. Tell me physics that are happening in nature, and tell me what is measurement and the various measuring instruments. That's what I want us to look at. Okay. So, let me quickly. Okay. So our learning outcome number one. So once I mention the learning outcome, then we should be able to look at it before we go into the other one. So the first learning outcome that we have for today is what is physics? What is physics? By the end of today's class, you should be able to define physics on your own, offhand. Then the second learning outcome, what you're supposed to learn after today are you're going to tell me what are examples of physics in nature. What and what can you look around you and see and you say that this is typical physics happening in nature? That's the number two thing. The number three thing you're going to be learning today is that you're going to tell me what measurement is and why we measure. And you're going to tell me the three basic quantities that you need to measure and their units. And you're also going to tell me the measuring instruments that you need to measure those quantities. Okay? So take note of all these. Those are the learning outcomes. Those are things that you need to learn after by the time we are done with this class. So let's start with the number one. What is physics? How can you describe physics? So physics is a pure science that deals with the behavior of matter and energy and how it relates to other physical properties. That is what physics is. The pure science. So physics is a pure science. You should know that physics is a pure science, and it actually deals with the behavior of matter and energy. Very, very important. Whenever you hear the word energy, then we are talking about physics. Whenever you hear the word energy, matter, and motion, these three words have a lot to do with physics: matter, energy, and motion. So in physics, we are looking at the behavior of matter and energy, how they actually relate to other physical properties. And examples of physics in real life includes lightning. Lightning is what happens before you see your thunder. So lightning actually happens on the principle of physics. Then thermometer is what they use to measure your temperature. When you're sick, you go to the hospital Once you get to the hospital, the first thing they do is to take your temperature. So that device they use in taking your temperature is known as thermometer. Now, that thermometer that they are using to take your temperature was built on the principle of physics. So you need to understand how heat makes something to expand. That is how thermometer was used. Then you talk about motion of your car, your automobile moving. All those are examples of physics in your everyday life. So for you to understand the working principle of a motor car, you need to actually understand physics. And that is why we teach you physics in school. So you learn physics in order for you to be able to do a whole lot of things. Okay, so the learning outcome for today, number one, is settled. Definition of physics and examples of physics in our everyday life and in nature. So the definition of physics is that physics is a pure behavior of matter and energy and how it relates to the other physical properties. Then examples of physics in nature includes driving, lightning, and thermometer. So those are examples of physics in nature. So you need to know this. So also how your camera works is also physics. So this learning outcome is completed. Okay, so let's move forward. Let's look at measurements. So that's the next thing we are supposed to learn. Measurement. So why do we measure and what is measurement? So before I started with physics, I explained to us why we needed to be measuring, why we need to measure. If you don't measure, you will not be able to compare the sizes of things. If you come and tell me that you are taller than your dad, if you tell me you're taller than your dad, I will not be able to actually know how taller you are to your dad. But if you tell me the height of your dad and your own height, I should be able to estimate how so much tall you are than your dad. If I'm looking at you and I'm looking at your dad at the same time, I should be able to know who is taller than who and by how much you are taller than your dad. But if both of you are not standing in my front and somebody comes and tells me that you are taller than your dad, I will not know how much taller you are to your dad. But if the person comes and tells me that you are 2 feet tall and your dad is 8 feet tall, then I should be able to know that actually your dad is so much taller than you. Or if the person tells me that you are 8 feet tall and your dad is 2 feet tall, I should also be able to decode that you are so much taller than your dad. So how do I get that 8 feet tall and 2 feet tall? By measurement. So I need to have measured your height and compare that with the measurement that I got from that of your dad. So measurement is very important in physics. Most calculations you're doing are from uh, numbers that you get from measurement. Okay. So now that you've known why we measure, you need to know the three major three major quantities that you need to measure in physics. Those three quantities are known as length, mass, and time. Length, mass, and time. They are basic quantities. You need to measure them. You need to know their units, and you also need to know the instrument that you can use in measuring them. So you have them as what? Length, mass, and time. So these basic quantities are also called fundamental quantities. They are also known as fundamental quantities because they are basic. You need to learn how to measure them. From the measurements you get from them, you can now be able to extrapolate other measurements for other quantities known as derived quantities. So the three of them are what? Length, mass, and time. The three major fundamental quantities. So from them you can be able to actually get other quantities that are called derived quantities. So JAMB is going to ask you, very, very importantly, JAMB is going to ask you which of the following is not a fundamental quantity. Which of the following is not a fundamental quantity? So if you don't know the fundamental quantities, you will not be able to know the one that is not a fundamental quantity. So what are the fundamental quantities? They are length, mass, and time. There are other fundamental quantities, but these are the major fundamental quantities that we have in physics: length, mass, and time. So why do you call them fundamental quantities? Because they are basic quantities from which you can get your derived quantities. Examples of derived quantities are quantities like velocity. Now, if somebody tells you to calculate velocity, velocity is distance over time. So distance is length over time. So distance is a fundamental quantity because it's an expression of length all over time, which is also a fundamental quantity. So you have two fundamental quantities coming together to give you a derived quantity known as velocity. So you see that you can actually combine the fundamental quantities by multiplication or division in order to get the derived quantity. Okay, so JAMB is going to ask you which of the following is not true about fundamental quantity? Which of the following is not true about fundamental quantity? So what is very true about fundamental quantities is that from fundamental quantities you can get derived quantities. And fundamental quantities are actually basic quantities. Okay, so that is very, very important. So what are the examples of derived quantities that you get from fundamental quantities? You have good examples are velocity, acceleration, and force. All of them are derived quantities. Okay, so you can see from the notes that I have here, the fundamental quantities are length, mass, and time. And the unit for length is meters, the unit for mass is kilogram, the unit for time is seconds. Then other fundamental quantities that are not this one I've mentioned are electric current, luminous density, and amount of substance, which is in mole. Also, thermodynamic temperature, theta, is also a fundamental quantity. So when JAMB asks you which of the following is not a fundamental quantity, they are going to have length, mass, time, then thermodynamic temperature, and they are going to put something like velocity. So you should know that velocity is not a fundamental quantity. So take note of the fundamental quantities that we have: length, mass, time, and thermodynamic temperature. So we also have electric current, luminous density, and amount in moles. So those are the fundamental quantities. Whereas derived quantities include velocity, acceleration, force, um, weight. All those are all derived quantities. So make sure you take something out of today's class. We'll define what physics is, and we'll give you examples of physics in nature and our everyday life. Then finally, we are concluding the class with the various fundamental and derived quantities. Okay, so you can see them on the board and you can take notes. Please take note of the definition of physics and examples of physics in real life, and also take note of the uh, quantities, the fundamental and derived quantities. Okay, so the last thing I want us to look at today is the measuring instruments for measuring the fundamental quantities. So if you want to measure length, what do you use to measure length? If you want to measure mass, what do you use to measure mass? If If you want to measure time, what do you use to measure time? So JAMB is going to ask you, which of the following is not a length measuring instrument? So the length measuring instruments, that means instruments that you can use to measure length, they include vernier calipers, meter rule, micrometer screw gauge, and tape rule. So those are the 4 instruments that you can use to measure length. Number 1 is meter rule, the rule that you use in your class. That's what we call meter rule. Tape rule is like the rule, the tape that um, tailor, when they want to get your length to sew clothes for you, that's what they use. Then you have micrometer screw gauge and vernier calipers, which I'm going to teach you how to use. So all those are examples of length measuring instruments, depending on how on the magnitude of the length being measured. If they are measuring something that is very small, they use micrometer screw gauge. If they are measuring a length that is bigger, they use vernier caliper. If they are measuring something that is substantial, they use meter rule. And if they are measuring a very long distance, they can now use tape rule. So those are the 4 instruments used in measuring length. Now let's get to mass. To measure mass, you use what we call beam balance. That's what you can use in measuring mass. Beam balance. Now, to measure time, you use stopwatch. So most of us, we wear watches. Watches are used to, you need them to check time. You can also use them to measure actual time that something takes to happen. So the best type of instrument to measure the time that something takes to happen is known as stopwatch. Okay, so with that, I'm going to be giving us assignments now. So number 1 assignment, please write. Victoria, take down the assignment. Write. Every other person should take down the assignment. You're supposed to submit to WhatsApp. When you write on a piece of paper, you snap it with your phone, then you submit it to WhatsApp so that I can go through it and check. So assignment number 1, define physics. So you can play this video again so that you can listen to what I defined physics as, and also every other question that I'm going to be asking now. So number 1, define physics. Number 2, give 4 examples of physics in our everyday life. Number 3, what are fundamental quantities? Number 3b, state the 3 fundamental quantities, their units, and their measuring instrument. The 3 fundamental quantities, their units, and the measuring instrument. So it's not just 3, there are up to 6 of them or 7 of them that are listed today. But just list only the 3 major fundamental quantities, their units, and their measuring instrument. Also, then finally, number 4, what are derived quantities? Give examples of derived quantities. Okay, so those are what we're going to be looking at. I don't want to take this so long since we are resuming again today, so that people that will be joining from some other time will not miss much. Okay, so please let's take note of these and submit the assignments so that I can mark them. Until then, see you when I see you. Thank you and God bless you.
Hello, sir.
Yeah, Victoria,
The answer is that we are doing the assignment before.
you say?
But we are doing it before, sir.
Yeah, I've done this class before actually. I'm just repeating it because of. Okay, you mean the assignment?
Yeah.
Yes, just redo it again. It will make you to refresh your mind on them. Yeah, ba?
Okay.
Yeah, just redo it.
All right, thank you, sir.
Yeah, it is gonna register in your brain. Once you
Okay.
reduce it, will permanently register in your
Oh.
brain, and so that as you are moving, it will be flowing.
Okay, thank you.